Hey everyone, this is Andy Melbuff, and this video is going to take a look at using Desmos Activity Builder to generate student interpretive feedback with graphing. Student interpretive feedback is when a student submits a graph or they sketch a graph and they can click a button or press submit and they get some instant feedback as to how their graph looks, and they can make some adjustments if need be. So you're looking at the student preview screen right here, and this is a sketch component right here. Here's a note component giving some directions to the student, and then there's a button and it's labeled Check My Work. So as a teacher, what I might want the student to do is sketch the graph of this quadratic equation that's in vertex form, y equals x minus 3 quantity squared plus 1. I'm looking for them to graph a parabola with some key features. So what I would want the student to do is recognize, okay, in my equation here, I'm going to have a vertex at 3, 1. So a student can go over here and the pencil is available to them and they would put a point at 3, 1. And the student would also be able to calculate the y-intercept by putting 0 in for x, squaring the negative 3, which is 9, and adding 1 to get 10. So the student could put a point up here at 0, 10, and they would have a mirrored point on the other side of the parabola at 6, 10. So just 3 points gives us the rough outline of what this parabola might look like, and the student can sketch. Now, sketching with the pencil tool and a cursor is really, really shaky. It's very difficult to do. I'm going to show you how shaky it looks. As I'm using my cursor, you can tell it looks like I've got the jitters here. But a student might sketch a parabola something like this. Now, that's not ideal looking, but we want them to see, did they hit the correct points? Do they have the right idea? They can check or select Check My Work, and you'll see the graph come up on that same sketch pad showing them how close they are to having the actual graph. So they can make some instant decisions. Do they need to change something? Do they need to erase and start over? This one's pretty close. It's hitting the key points. It's just it's not very smooth. So how will this look from the teacher perspective in building this? Let's take a look at that. Okay, I'm in edit mode here. And what I've got here is a duplicate screen. I'm on screen number 2. Screen number 1 was the one I just showed you. Screen number 2, I've already added a graph component, and I've already added the identical note component and a button component. I've identified the button as button number 2 because I'm on screen 2, and I've given the button label Check My Work. Okay, so the students will see that when they go to press it. Now, what I need to do is put into the graph what I want them to graph. So rather than just type it in again, I typically use copy and paste. This is the check I want them to be able to have. So I'm going to copy this. I'm going to go into the graph. And it should be a blank graph, sorry. And I'm going to paste it in there. And here's the parabola we want. But we don't want the student to see that right away. So we have to, in a way, hide it until they press their button. So what we're going to do is we're going to go back in here to this graph, and I'm going to enable a timer. I'm going to put a condition here. Some call it a domain restriction. I'm going to say I only want this graphed, and I use a curly bracket, when x is less than t. T is going to represent time, and right now Desmos doesn't know what that is, so it doesn't have anything graphed here. If I add a slider for t, you'll see here that part of the parabola is graphed, but not all of it. The only part of the parabola that's graphed is the part where x is less than 1. Okay, and that's because the timer is here at 1. Watch what happens as I increase this timer. You see more of the graph being shown here, or less of the graph being shown. So I'm going to have a T in here that I'm going to tie into the button. I'm going to delete this slider so nothing shows yet, and I'm going to account for that T in the computation layer of the graph. So I'm going to click Done in this component, and I'm going to go in here to the computation layer, and I have a little note started up here. A note is nothing that the computation layer acts on, but it's just going to describe what I'm going to do below this. So I want to create a timer that uses T. So one of the sinks available is a number. I'm just going to press N. Here are the available sinks or functions, and I'm going to choose number. I want this number to be known as T, and I want that to be tied to the button. So I'm going to start typing B. Here are my button options. I'm going to choose button number 2, and the source is going to be time sense press. Now, what this is doing is saying the number T is going to be assigned once button number 2 is pressed. The timer will start at 0 and it will run for 10 seconds. So that's what this part right here is doing. It's going to assign the number T a value of 0 once the button is pressed, and then it's going to run up to 10. So let's see how this looks if I go to preview mode. Now, you'll see up here, part of the graph is being sketched already. I don't want students to see that. So I need to make an adjustment in my graph. So I'm going to close out of the preview mode. See, right now, T is starting at 0, and part of that graph is showing. I don't want that to be showing. So I'm going to reduce this by a number like 5. Now, if I could click preview, I don't see that upper part of the graph over here. There's still some more way up here on the upper left, but in this viewing window, the student won't see anything. But if they click check my work after sketching, you'll see a parabola start to come down from the upper left. But boy, is that slow. Here comes the parabola. Oh, and it runs out of steam right here. It stops because the timer's run for 10 seconds already. So we want to speed this up so that the student sees more of the right half of this parabola. So we have a little more adjusting to do. I'm going to go back into my graph component, and to speed up a timer, we can simply put a coefficient in front of T. For example, if I put a number 5 in front of the T, watch what happens. I click preview, I'll click check my work, and you'll see the parabola come in much faster. And the student will see all of the parabola that you want them to see. So this is how we can use Computation Layer to give students interpretive feedback when they sketch a graph, and then they can check it and compare it to the actual graph. Another form of student interpretive feedback with graphing can be what I would call matching a graph. Here, you see a graph component with a parabola already graphed on here in a dashed line, and we're asking students to look at what they see, interpret some of those key points that they see, and enter an equation to match it. Now, it says here in factored form. In Algebra 2, we use factored form to take these key points and be able to graph. So let's see how this looks from a student perspective. If a student were to type in the equation of a line, I'm going to put something that's clearly wrong, y equals 3x plus 1, just so you see the interpretive part. And as a student, I press submit. There's the student's graph, and clearly it does not match the parabola we want it to match. So ideally, what we would want is the students to identify, okay, over here, I've got an x-intercept at -1, and I've got another x-intercept at 4. So I would want students to type in linear factors that will produce those x-intercepts. So again, I might have a coefficient in front here. I don't know yet, but this is where the students' interpretive feedback part comes in. They can press submit and see how their graph looks. Look, that matches perfectly. No coefficient is needed in front here. They've successfully matched this graph by pressing submit, and you'll see what they typed in. It's matched right over the top of that. So let's exit the preview mode and see what we have to do in the teacher background here. So like we saw earlier in this video, I've created a duplicate of the slide you just looked at. This is slide number 4 now. You just looked at slide number 3. And slide number 4 has a graph component. It's got a note component with directions for the student. And it's got, this time, a math input component. There's no button on this, no button needed. And I've identified this as input number 4. Well, I want students to match the graph that I put in here. So I need to put in the graph that I want them to match. So using the one I just had, I'm going to type it in factored form. X plus 1 is one of the factors. And X minus 4 is the other linear factor. And there's basically the same graph we just saw. But I want this to be dashed so that the student's graph can override it. So I'm going to change that to a dash right there. Now, next, we also want to have graphed what the student types in. So the students are going to type in something, and we want it to be graphed here. I'm going to type in y equals, and then I'm going to write a function, f of x. The Desmos doesn't know how to interact with this because it doesn't know what f of x is, so it gives you that little warning symbol. If I were to instead type in just a simple number like 1, you'll see it does know how to graph y equals 1, that horizontal line, but I want this to be in a different color so it stands out when the students look at it. So I'm going to press and hold on the style, or change the style, not to dash, but to blue, excuse me. And now this will be what the student graphs, but again, I don't want them to graph y equals 1, I want them to graph f of x. And we're going to let the function f of x be defined in the computation layer that's in the background of this graph. So I'm going to click Done, and we're going to go into the computation layer now. So in my graph component, I'm now going to go into the computation layer, and I've typed in a couple of notes for just my use here. In the graph component, I want to graph y equals f of x, but we don't know what f of x is yet. We want to create a function in this computation layer that's going to tie that to the student's input. So we're going to use the sync function, and we want it to be labeled as function x. Now, functions, we're going to use simple function here, and then I have to tie that to the student input. So the student input was input number 4. I'm going to choose input number 4 dot LaTeX. LaTeX basically is saying whatever the student puts in that input box, it's going to be read as mathematical notation. So you'll see there's no little warning symbol. So this is basically going to say f of x is going to be defined by what the student types in their input box. Now let's see how this looks in preview mode. If the student types in what we want them to type in, oh, look, what we're getting is an opportunity for students to get some check. So what we need to do is go back in and put a timer in so that after they press submit, then the result is graphed. So I'm not even going to finish this because I can see this is not what I want to have. So I'm going to go into my graph component, and like we did on the previous screen, I'm going to add a domain restriction, which basically is going to insert a timer. So right after the parentheses on f of x, I'm going to use a curly bracket, and I'm going to use x less than, and I'm going to use 5t. That will speed up the graph a little bit when it gets plotted, and I want to start it further left, so I'm going to subtract 10 from that. Now, Desmos doesn't recognize two things here. It doesn't recognize f, but we've defined that in the computation layer, so we also need to define t in the computation layer also. So I'm going to exit this graph part right here and go into the computation layer for the graph. And below where my simple function is, I'm going to type number like we did before. I want the number t to be based on input number 4 time sent submit. Before we had button in here, but now it's input number 4 time sent submit. So let's see how this looks if we hit preview. The student might type in y equals x plus 1, in parentheses, x minus 4, and their graph is not showing yet because they've not hit submit. Once they hit submit, the timer will take over, and you can see that the student gets some instant feedback. In this case, they've matched it properly. If they've typed in something incorrect, for example, they typed in x minus 6 instead of x minus 4, you can see a different parabola being graphed And this is something that visually the students can instantly see, okay, I've got to make an adjustment. So that's how we can account for student interpretive feedback in graphing using the computation layer of Desmos Activity Builder.